Welcome to Flipped Classroom. We are looking at the unit of probability, and today's lesson is two-step experiments. Our learning intention today is we are learning to calculate the total probabilities of two chance probability experiments. And our success criteria is I am successful when I can represent probability using a two-way table, find the sample space of a two-step experiment, and calculate the probability of two-step experiments. So let's look at a standard deck of cards. We've got no jokers here. What's the chance of drawing a black card? What's the chance of drawing a heart? And what's the chance of drawing a queen of diamonds? The chance to draw a black card is a half because half of the cards are black. So the chance of drawing a heart is a quarter because 1 out of the 4 suits is hearts. And the chance of drawing a queen of diamonds is 1 out of 52 because there is only one queen of diamonds out of all of the 52 cards in a deck of cards. Two-step experiments are when there are two independent probability experiments happening that form the total experiment. So each of the steps do not directly affect each other. We can use a table to represent the sample space, and we can then use that table to calculate the probability of those events happening. So some examples of two-step experiments are flipping a coin and rolling a dice, picking a token from different bags, or rolling two independent dice. So here's an example. We have two bags. One bag has a red, a green, and a yellow token in it, and one bag has a white and a black token in it. Now we can't see in these bags, and when we draw out the tokens, we cannot tell the difference between the tokens until they're drawn out. So we can create a sample space using a table. So for bag 1, I've got my red, green, and yellow. For bag 2, I've got my black and white. I can represent it in the table that is on the screen. I've got red, black as one option. I've got green, black as another option. And I've got yellow, black as the third option. And I could also pick out a red and a white, a green and a white, and a yellow and a white. So I can write out the sample space for this by using the set notation. So I've got my sample space character there equals curly brackets to say this is the set of, and I've got all 6 of those options in my sample space. Let's have a look at a couple of questions that you might get. So I've got this example here where I've rolled 2 dice, and when I've rolled the dice, I've recorded the numbers on each of the dice. So down the left-hand side, I've got the first dice. Across the top, I've got my second dice. And these are all the options. So I could get a 1 and a 1, or a 1 and a 2, and so on, all the way through to 6 and a 6. So here are my questions. I've been asked how many outcomes there are, how many outcomes contain at least one 5, and what is the probability of getting at least one 5. On the left, I've got my thinking, and on my right, I've got what I will show my teacher. Part A, I'm going to look at the array and count how many outcomes I've got. And I've got 6 in each line, so that's a total of 36 outcomes. So I'll write down that there are 36 outcomes when I roll 2 dice. For the next one, I need to find all the outcomes that contain at least one 5. So what I do is I go through and highlight or I circle them, and I notice that there are 11 of those outcomes that have at least one 5. Now be careful with the words there. It's not 1 5, it's at least one 5. So we need to include when I roll a 5 on both dice. So I will write down there are 11 outcomes that contain at least one 5. So for the last part, what is the probability of at least one 5? I need to use the equation that I learned when I did theoretical probability. And if you've forgotten about that, you can click on the card in the top corner. And our probability is the number of favorable outcomes over the total number of outcomes. So we've just worked out how many favorable outcomes. There were 11 of those. And how many were total? There were 36 total. So all I need to do is write that down. The probability of at least one 5 is 11 over 36. Now, if I could simplify those numbers, I'd make it into a simpler fraction. Our reflection for today is, can we predict how many outcomes there are based on the 2 independent steps of the event? As always, like the video and subscribe for more videos on maths.